Welcome in the Flock office, our new office. Today we had a Flock day. We worked on all kind of cool, innovative stuff. And we would like to close this day by a talk of Frank. I bumped into Frank on the Kotlin Dev Days and we catched up and he talked about a great tool he's working on. And yeah, he will explain us all about it in the coming hour. Thanks.
Thanks. Oh, thanks Willem for introduction. Nice to see you all. Also some familiar faces. Actually some people who worked on the things I'm partially going to be talked about. I didn't forget you, Julius. So who am I? So I'm Frank Koten. I'm a tech lead at bol.com. I've been working there for over 10 years now. I'm the tech lead of a product that works on the basket, checkout and the order confirmation. So basically the end of the shopping experience of the customer. And as a tech lead, I'm busy at two fronts. So I'm busy at the product itself. In the product itself, we're busy with craftsmanship a lot. So how do you develop code that is sustainable? How can you make it extendable? How can you design for growth? How can you design to actually start off in a mono repo and in fact deploy to separate deployables in time? So, hey, I wrote monolithic. That was not what I wanted to write here. And of course, I'm totally blank now what I did want to write it. So anyway, horizontally, I'm working on API first tooling. We consider the Swagger ecosystem very weak, but we love API first. So we're working on the toolkit, working on analytics, and more recently also on performance. Well, it's always been a love of me, but currently we're moving to the cloud. That's what this talk is mostly about. And we thought, okay, perhaps we can do better, bring a better offering to the Kotlin and JVM community than we currently do with the tooling that most of us are familiar with. So what I'm talking about performance testing, but also performance testing in isolation, and I'll get to that later. So what I think is that performance testing is this underrated thing. It's often an afterthought. It's but it's something that we should pay more attention to. And when you go to the cloud, it all of a sudden becomes really, really important that you pay attention to this. So a brief history of bol.com. I'm going to tell you a bit of a story of how we went to the cloud and what the repercussions and realizations are that we had. So we started at Schuberg-Philis. Anybody know Schuberg-Philis? Okay. It's a beautiful place. So luckily we departed there. So we deployed this King Kong monolith once a month. It took hours. This monolith was performance tested by performance testing. So basically no developer had any clue before it went live how the thing would perform. And if halfway we realized something was wrong, it took also 2 hours to roll back again. So it was a beautiful time. Basically we had zero autonomy. And we had zero idea about the cost, right? What does it cost to run this software? I don't know. So luckily we evolved. So we ended up going to a private data center. Of course, it's a project of years. We started building microservices. So we had this monolith, started taking stuff out, and microservices within quotes, because that's what they loved it to be, but it was far from what it actually was. So we started doing some continuous integration, mostly Jenkins. Again, these pipelines were managed by a central team. So as a developer, you just clicked something, you created a configuration file, stuff was generated, nobody had any clue what it did. You were not able to evolve it or influence it. But bottom line is, it was, again, far, far away land that this was happening in. But we got a performance center, yay. So this was, well, there were some people really proud of creating this, and back in the day it was very useful, but it actually was a draconic piece of software. It was some Bash, Perl, PHP, really antique JavaScript slapped together, but it did the job, right? Everybody all of a sudden was able to run their own performance test. So you had a version of your application. For that version, you had a certain performance test, and it was ran by this performance center. So we got some autonomy. Still clueless about what the costs were that we actually, like, this is going to hit production. We think it performs well. So we still had zero ideas about the actual costs. So then we were lucky. We're lucky, well, I think we were lucky. So we went to the cloud. We're still going. It's a process of years, and it will be a process of years to come. Hopefully somewhere in 2024 we'll be fully there. So last month, I think that the number 1,000 of our Spring Boot services actually got deployed to production. We're having our own application framework, Axel, which after years also got their own team. So we're starting to move really into microservices. So then you see an opposite trend. Maybe not everything should really be a microservice. Or now we have 40 repos to deploy one system. This might be a bit overkill. So when we went to microservices, I'm now going to, this is the word I forgot, a modulith. Yeah, so basically we're advocating modulithic architecture nowadays. Well, great. All of a sudden we had GitLab, we could build our own pipelines. Hey, we have full autonomy. Like everything we do, we control. We control the code, we control the test setup, we control the deployment setup, we control our own nodes. Oh boy. So, all of a sudden, we have full autonomy, but we are also fully responsible for the cost. So, the autonomy gives you a lot of responsibility all of a sudden, right? So, in the data center, you had a fixed-sized cluster. So, you had 10 nodes, you could blast it, and if those 10 nodes ran out, well, unfortunately, everything runs out. That's your max capacity. There's no scaling. It was paid for up front, and we knew the cost. So as a company, it was very predictable what the costs were. We can go no further than the stuff that we already bought. Okay, pretty simple. Then we're going to the cloud. So we're renting compute power now, right? We don't have an X amount of compute power. We scale horizontally on demand. So the costs grow horizontally on demand. So the costs are dynamic. So this can be like quite dramatic if you do not orchestrate these things right. If you have a naive scaling setup, the world might light up as a Christmas tree because you're spinning up nodes like crazy to accommodate for a certain peak in load. So autonomy and responsibility is closely tied together. And then, all of a sudden, everybody was like, okay, we have no clue what this costs. We have no clue, because we never needed to look into what the costs were. So we never needed really to optimize for load. So all of a sudden, we needed to rethink how we are going to build, test, and deploy our software. So we needed to become cost efficient, mostly cost effective, right? So if we want to have a certain load, we want to make sure that we use as little compute resources, either in storage or a CPU and memory for our pods, as possible. Yeah? So we wanted to be efficient. And then you want to develop this scaling strategy. So I know one node can do X requests per second. I know it dies at X plus Y. Let's make sure we cap it at X. We deploy that and we scale horizontally as soon as we start reaching that X boundary. You need a scaling strategy, and it needs to be based on data. So you all of a sudden have a responsibility to performance test to figure out what your nodes are capable of. More importantly, when they're going to die, because that is the point you'll never want to reach. So then we get this, okay, performance testing apparently is really important, right? Because if we don't know what we're doing, we're scaling naively, this cost's gonna explode. And then if you start thinking about it, some fun stuff starts happening. Okay, so what is actually the quality of a service? Okay, so you have the function, right? We test functionally. We do that usually in isolation. Then you have the delivery of a function. So I'm going to run this functionality on the production. And then you have the costs associated with these things. So the quality of a service is not only about that it does what it's meant to do. It's also how it does that. Okay, so if you look at what we've learned from functional testing, and this is also where the isolation part becomes interesting. I'll iterate on that later. But so you spin up your application, you use WireMock or whatever kind of mocking tool you use. We use WireMock a lot. We test against the API. But bottom line is we stop at the boundaries. We're not going to test the whole freaking landscape, right? Because we do not control those things. So you focus on what you control, what you can manage, and you try to deal with everything that can happen in the rest of the world so you can accommodate for failure and those kind of things. If you start mocking your boundaries, what you do is you trust the contract. You have an API, you've agreed this is the API. Hopefully you've got some contracts about this is the latency, this is the throughput, and then, well, you trust that or not. Anyway, so what we do is we verify this in the build. So in the build pipeline, we run all these tests. We run unit tests, a lot of them usually a little bit less integration test, a bit of mocking, a bit of stopping. But most of all, everybody takes this like delivering a feature, you make sure that you test it functionally, right? That's like completely normal. Actually, it's part of the requirement. Usually it needs to do this. Okay. And then we go to performance testing, and all of a sudden, apparently we have learned nothing. So we don't do stubbing. Usually if you have an edge server, you test that, and you test the half of the landscape behind it. So we don't focus on what we control, we focus on what we control and everything behind it. Which contracts? How many of you run a performance test in your build? And fail a build if you don't succeed in that test? Is it ever like in the requirements, this should perform properly? I mean, when I started thinking about this, it got really weird. Like, why on earth, if the quality of a service means it delivers the function and it delivers that in a timely manner and in a cost-efficient manner, okay, that's odd. So the ugly truth is that we tend to have a lack of ownership, at least at Bol.com. Like, it's always an afterthought. And when something explodes, then we start looking into it. Or at Bol, of course, we have what we call the holiday season, Christmas, do a lot of sales then, and we start prepping for that. But it's never in our day-to-day work. So what I think we should do is make this a first-level citizen. So 2 of the 3 factors, so you have function, delivery, and the cost of those 2, only one is covered by this functional test. The delivery, like if you have a service like Bol.com, you have a landscape and your performance goes down, your sales go down. I mean, these are directly related. So it's not only that you deliver the function, also is that you deliver the function in a timely manner. So it's actually crucial for a company like Bol.com. And then if you scale naively, maybe you are really fast, but you're spending more money that you get from revenue. Would also be kind of bad. Right, so that this is not on top of mind, usually it was a problem already, but going to the cloud makes this problem a lot bigger. So I think the proposal to do is like we integrate this to our way of working, right? So you have a test, you have an application, you build it, then you have a certain baseline in your build. I mean, you can't do a full saturation test or a crash test because then every build will take hours. But what you can do is just have a baseline, run it for 3 minutes and see if it wildly varies. At least you have some idea about if you did something really silly, right? And then periodically you want to probably do with the JVM or memory managed language, you want to do some saturation tests, so have it run for a longer time. But usually with smaller changes, it is not that important to do that as often. but you probably should do it every week or so. And then there's the stress test. And the stress test is interesting because if you take one node, let's say you're an integrated server, you take one node, you bombard it with requests slowly but steadily. At some point, the machine with a certain set of resources will start malfunctioning. So that's the breaking point. So you can use that kind of knowledge for scaling, right? Like take 20% off, you have a zone of 20% of buffer, so you're going to trade this resource usage that is useless for a certain sense of security and make sure your applications keep on well behaving. So integrate your tests with an observability stack. Everybody of us want to be lazy. What you see is we have a performance test platform, tests are scheduled, nobody ever looks at it. So you can't depend on people going there, you need to go to the people. So integrate this performance test with your platform and alert. Let the stuff come to the people, bombard them with alert and text messages, whatever. So alerting first, dashboard second. So people start building these beautiful dashboards. Yeah, that's great. Only you don't need them if nothing is wrong usually, unless you're like really enjoy watching the grass, but usually is something is wrong, and then I go investigate and see what's going wrong. I'm going to look at the data. So where people always build dashboards first, they would say build alerts first, and then dashboards to figure out what's wrong. And then you have this feedback loop. Hey, we saw this on test or arc. Let's project it to pro, do a test, or we see this on pro, let's reproduce it, but make sure that those learnings keep on flowing back and forth. So I think that's relatively often true. You still have really sucky developers, even though they're happy. But I think that if you have your developers are usually more productive if they work with things they enjoy, right? If you're working with this framework that is always having it's like having a fist fight in code, that's unpleasurable, you'd rather not do it. You'd rather go to this thing that facilitates what you want to do, that helps you, and this is important. I mean, we get more productive, it's better for atmosphere, it's better for morale, if we can use tooling that helps. So then, there's this thing called developer productivity. So we're going to the cloud, right? We need to start running a load test to make sure we can manage costs, we can scale properly. And then you need to start making choices like, okay, what is the tool set that I'm going to use to run these tests? And often, I think it pays off for people to stay within the ecosystem they're familiar with. Right? So if you don't really need to learn new things, you probably become more productive easier. It's also easier to make the step, therefore it's often easier to motivate people to make that additional step. Or in other words, I think it's important that we take away the things that are not helping people. Take away as much as the boundaries and of the problems you can have, you can possibly envision. And people are more inclined to start doing certain things. So you want to work with recognizable patterns, so think that you already know, that you daily do, and you will probably want to reduce a learning curve. So if new people join your team, if they really need to work themselves into some technology to get performance tests up and running, and then I go back to the previous point, that's probably not a really pleasurable experience. I'll later tell you that I hate Scala and Gatling. Well, I don't really hate Scala, but I hate Gatling. So what is important usually is from your ecosystem. So you're writing a JVM app, I'm now exaggerating here, but you're not going to unit test that in Golang. Why? Because it doesn't make any peeping sense. It's a totally different language. I'm writing my code in Java or in Kotlin, I probably want to test it in Java and Kotlin. And I probably want to use the same library. So most of us work with REST services. Cool. We use often web clients to call other web services. Then you have the choice. I'm going to either write my performance tests with one of those clients that I know, or I'm going to learn a totally new tool, and I'm going to use that to write my performance test. I mean, that's an option. It's always an option. There are really great tools out there. But if you look at how can I get people as productive as quickly as possible, it's probably not your best option. And then there's the tooling. So a lot of performance test frameworks, they come with reporting functionality. Well, that's great. But it kind of goes against the philosophy I shared before that I want the things to come to you. The secondary, I need to learn what these dashboards actually tell me. Usually they're quite intuitive, but in the end, it's yet another tool. And I need to learn to understand what the metrics mean or the graphs mean that report shows me. But probably, I hope, you already have an observability stack on production that alerts stuff to you and it provides metrics and graphs. So if you already have that stack, why not use that to see if your performance test runs successfully, right? Why would I learn another tool if we already have one on production and we trust that tool to tell if your stuff is good or bad? I don't know. So, then here's my darling Gatling. So, I think the tooling that we've been using at Bol.com is, well, I call it misaligned. I could use a lot of heavy words. I chose this because I have no clue what it really means, but it doesn't fit. I don't think it fits the purpose. It doesn't fit our day-to-day work. For example, Gatling is a Scala, and Scala is a really cool language actually. You can do really cool stuff. However, Gatling is a beast to get familiar with. And if you write code in Gatling, 2 weeks later you probably need to completely relearn what you did. Is that a productive tool? I think not. Is that a productive tool for 90% of the developers out there? Absolutely not. And then we have a lot of really cool tools in different languages, like Locust. Pretty freaking amazing tool. K6. Also really cool. You have Vegeta, Golang tool. I actually think they're all really cool. But then I come back to, I'm not writing my unit tests in a different language, in a different whatever. I prefer to stick to something in the language using the libraries that I am already familiar with. And then JMeter, actually I'm not sure if everybody knows, but they recently, like last week, released the JMeter DSL. It's amazing, because then you can use really old crap with a new DSL. These are all tools that do the job, right? But then I come back to happy developers are productive developers. I strongly believe that if you give people something that makes them happy, that makes them joyful, they're more inclined to do it. So if we say performance testing is not within our daily routine, and there are reasons for that, I think we might want to tackle that problem. So there's a big gap between performance testing and functional testing. If we're going to the cloud and do not do proper performance testing and proper scaling, we're going to waste a lot of money. It's not part of the process, and I cannot help anybody to get that into their process. And the tooling doesn't really align with what I think, doesn't really do what I think it should be doing. So what we can do there is we can make them an offer they can't refuse. And this is basically what we did at Bol. What I did at Bol, and I was happy that a lot of people enjoyed it. But as usual, I needed something creative to do. Julius might know in 2018, we actually, it was 2018 already. We started tinkering in a hackathon with see if we could use coroutines and web client to write a performance test, because let's all be fair, 9% of the performance, what you do in performance testing is usually quite trivial stuff. And this is also why I think Gatling or a lot of other tools don't really make too much sense. Because those tools are general purpose tools. So they're meant to do everything. So everybody who wants to do a test comes with feature requests. So you end up with this. Well, that makes it really hard to keep something simple. And I think something simple is good enough for the 90% use case. So, okay, so we decided, like, okay, let's tinker a bit. We got some ideas. We think we know how we can make people happy. So what does a performance test actually entail, right? Well, there's actually 3 things. So you have the amount of users that do something over time, right? So, for example, with bol.com, you have at any given point of time, you have X users interacting. You have a nice curve, like around 8 o'clock in the evening, as the most people actually shop. And you have a couple of different workflows. So you have the amount of users over time, you have the test, so what the users do, and you want to see if that was successful or not. Now you want to report on these things. So we want to know, like, okay, if I have a failure, is it functional? Like, did something go wrong in the back, or was it latency that I went over? Like, all kinds of like, it is what you consider important in your test, right? I can't judge that. And if you have a performance test running, it's running on a certain server, and at some point you hit the limitations of that single machine, you want to be able to grow beyond that if the load is not enough for your system under test. And so those are some really simple things. So what are users doing? How many of those users do I have? And I want to know how it went. Of course, you can explain every piece of software in these simple terms, but that's not really the point. So this is when we started tinkering with Kalash. We called it Kotlin back in the day because every cool Kotlin tool needs to start with a K, obviously. And because of our love-hate relationship with Gatling, we chose another weapon, a Kalashnikov, which started with a K. So this is how you end up with Kalash. And we had a couple of goals. So it should be really simple and elegant to work with, right? So it should be attractive to people. It should spark joy. Anybody marry Kama? No? So it should spark joy. It should have a very tiny footprint because I don't want to be offering support the whole freaking day. So one of the goals was actually to do as little as possible with the maximum effect. It should be library-like. So it should provide the scaffolding, it should provide the structure, it should provide something that abstracts users, it should abstract something that is a set of actions of user, an action, do something with metrics. But it shouldn't implement it itself. It should provide the ways to implement these things. And if you want to work it, you should just be able to pull the example, clone the example project, run the Docker Compose, so you have this Grafana, Prometheus, and whatever thing spun up, and you should start writing your test. Because I think if you need to write a whole freaking book about how to set stuff up, you probably lost half of the people. So if you can just create a run profile in IntelliJ, click, it spins it up, and you write your test, and you get metrics directly, people find that, oh, it's fancy. No, it's not fancy. Everybody can do that, but people like that you facilitated that. So if you want to go for adoption, it's probably, those things are probably the things that help things sell. So Kalash has a couple of core primitives, as I call them. I have no clue why I named it. I always try to come up with these smart-looking names, and then they don't mean shit. So Kalash has a concept of a test. And the test is basically creates the context of a user, and the user can run a scenario. So this sounds perhaps a bit fake, but the thing is that often you want to have a test where you, for example, say 20% does this, 10% does that, X% does that. If you want to model that quickly, elegantly, you often end up with, unfortunately, things that Gatling does, but you need to make things lazy, basically, to make it work nicely. you have a scenario. So it's a set of action that the user does. Whenever a user goes to your site, looks at the product page in bol.com terms, they click on add to basket, they go to the basket, they fill in their payment details, they click on payment, and they end at the order confirm page. That would be a typical scenario that you would use at the bol.com website. They have a context. So basically, this is the environment of a user. I mean, often, if you work with RESTful services and you work with authentication and you work with JOTs or whatever, then at the beginning, you probably want to log in. You want to have that propagated over the whole, over all the actions that you do during that scenario. What's this kind of gnarly if you need to start writing and now add the authentication header, and now add the authentication header, and this time you want to add the authentication header. So that pisses people off, so that's also a concept that happens so often that you probably want to facilitate it. So a thing a user does, an action. Also, Kalash in itself doesn't know anything about HTTP, remember? It provides scaffolding. So Kalash in essence measures lambdas. And it measures if these lambdas throw or not. You're able to give those lambdas a name, so we can report them in our metric system. So an action is a thing a user does. And usually locally you want to run against whatever, your local servers, or you want to run to some thing in Kubernetes with a port forwarded. So probably you have another host than you have on your test environment or your acceptance environment. So you want to do something with configuration. But again, this has been done 1,000 times, right? The JVM has means for this. So also in this case, we don't really write a lot of stuff. We just made it simple to use property files and to have one property file on your local machine and have one based on environment property overlay. I mean, that's what Spring does with the profile. So we try to keep it really limited. So we wrote a couple of plugins. So we're moving to web client in general. With the new Spring Boot, you're going to get declarative HTTP clients like Feign or OpenFeign. That's going to end up in Spring Boot natively in the next version, in Spring actually. But we use web client a lot. So we wrote a web client plugin, and we don't want anybody to need to learn a new client. So if you want to use whatever kind of client, you can write a tiny wrapper that integrates your HTTP client into Kalash. So this is why web client is also a plugin. It's not entirely true because we like more REST hard-coded it for the moment, but yeah. But it is in the plugin package, because so the idea is there. We wrote a plugin for Prometheus. We're going to expose metrics, so we want to know if a scenario failed, if an action failed, what the latency was, which errors occurred, etc., etc. So you can plot it in your favorite graphing tool. So Kalash knows only one thing about users. I want this many now. That's it. So if you want to ramp up or down, that's going to be a plugin called traffic. Feeders, so let's say you want to do something with users. If you start using one user and do all the calls at that single user, that's a really odd test. Also, it never happens in real life, hopefully, on your system. So we have a feeder. The name is stolen from Gatling, actually. But you probably want to have some configuration of a lot of users that you can use, or you want to have a way to call some user system to get all the users before your test start. Choices. Randomly pick a scenario. And of course, in our case, we want to integrate with Kubernetes. So we want so everything Kalash is written to do work on one node. Right? So it's just meant to exhaust this single node. And what we're saying is, okay, in the cases that we are dealing with, we don't need a central managed, something that manages load centrally, because it really overcomplicates the whole situation. Because in general, with our services, if we have one node, if we have one worker, a Kalash worker, generating 1,000 RPS, and it can't go beyond that, Well, you can have some sort of whatever controller that makes sure that X nodes are doing exactly the same amount of requests. Or you can keep it really stupidly simple and you say, if I want 10K requests, I have 10 workers. It takes away a lot of these complications. And for us, as a company, as Bol.com, this covers the load, like always. I mean, I'm not sure what people usually do, but yeah, I doubt that a lot of the companies need more complex tests. They really need extremely well-balanced minute timing of their tests. I don't think that's actually the case, often. Yeah? Yes, so, that being said, I'd like to go in a bit of code with you all. Wow, it's like nice timing. This is like I never did this before, so the timing is actually really nice. So I've got 20 minutes left to actually go into some code. But if there's anybody who has a question right now,
do you have something like a life cycle that set up for the test and clean up after a test?
Oh, I didn't mention actually the most important part. So Kalash lets you just write code. Joost in the back, he did something really nice. He wrote laat, and this is actually what sparked me to go back to the Kotlin idea. And one of the things that Joost did was really cool, we're happy to steal that. Is actually that you should just be writing code as you normally write code. So you're not forced into some DSL kind of thing. Pretty much everything that goes in normal code goes here. So if you want to do something before and after, be my guest. Because it's so free and open, we don't need to facilitate that. Well, it's not true. We need to facilitate a bit, but I'll show that in a second. Is there anybody else who'd like to...
Online question? Is there online question?
Online? So far not.
Good. Because then I can show some code. So, there we go. Oh, no. So basically this is how every Kalash test will start over. Every build will just be a main function. It uses Kalash as a starting point. And as I said, Kalash has two core concepts. Something with users. Oh. And as I said, the only thing Kalash actually knows is that you can go to a certain amount of users. I feel very inspired, so I'm going to go to 3 users today. And maybe you've noticed that I didn't say anything about time. How long does this test run? So, Joost, I still thank you for this, but Kalash has an event loop. It's actually super simple. Kalash is 250 lines of code, the whole thing, including the plugins. So users allows you to describe users over time. Because go to 3, well, this actually, I'll show you how this works in the hood a little bit later, but so this is just a delay function of Kotlin. So you go to 3. Let's say we want to have this test run for a minute. And you make sure this function sleeps for a minute. And you've just told Kalash, I want 3 users. Kalash, the only thing that Kalash knows is, how many now? Well, now 3. Now 3. Now 3. And Kalash works on a tick system. So it's every second. Because that's something you can reason about. I want 3 users starting their journey every 3 seconds. So every second. So this means every second 3 users start the journey. Well, it actually means, does anybody of you know the difference between an open and a closed workload? You see, this is so fun. Like,
It's about the amount of users you want to add in your system at a given time versus how much you want to add at every point in time.
yeah, exactly that. Exactly that. I always forget which one is which. But so one of the two is that you say, I want to add X users at any given point in time. And the other one is I want to keep alive X users. So you never go above 3 with one. And with the other one, if 2 are not done yet, it will add 3. So you have 4 running. So I think that model, 5. Yeah, thanks. My math never been good. Luckily, you don't need it to develop code. Yeah. So basically, but I think that's a bit of an odd model. We don't also use it. Plus, I could utilize the fact that users were not done yet to give you feedback. So let's say you're running a test. You want 1,000 users per second. And at some point in time, there are still 10 busy when the next tick comes. So what does this mean? Well, if the performance test thing is proper, it means that something out there is giving you back pressure. It's that simple. So something there is preventing you from moving ahead. So if you can measure that something that you're not able to run that much users anymore, you'll know probably that your system is failing to deliver. So this is not super useful yet. So this is what I said, we created the traffic function. So there's another thing, which is ramp. So let's say, oh. Right. God damn it. Something is wrong in my Maven setup, because every time I run Maven, I'm back at that. Thank you. Okay, so I'm gonna ramp to the target, 100, in this duration. So basically what Kalash does is it says, okay, you are at 3, you want to go to 100. So then you say, like, why not 103? Well, this reads way easier if you do it like this. The last number you see is always where it's going to end up. So you don't need to say 100 plus the 3 I had before. No, it's just, it's going to 100. And it's going to do that in a minute. So I think that's usually the start of a test, right? So I ramp up to that. I'm going to do, so I'm going to ramp, going to hold it, and then I'm going to stop. Or again, it's going to always end up at the last number you gave it. So it's going to end up at 0. You know you were at 100. You know you're going to 0 in a minute. Pretty easy. And if you have, so this is why it's not called ramp up or ramp down. This is why it's called ramp. Because it's just able to see what we have, where you want to go to, and it's going to see if it's a positive or negative number. It's going to see the duration, just going to calculate it. So if you look at this, this function is actually a linear step sequence. So you can actually also, if you want to have like really odd shapes, okay, sure, then you pass another function as a third argument. Linear step sequences do some very simple step making. Yeah, so that's the concept of users. So you have users over time. You determine what the time is by either have a duration for ramp or delay. So then, of course, you have the thing that those users are going to do. So let's start off with writing a test. So test can run one scenario. And often you want to have multiple scenarios. You can have those, but you don't need to. So if anybody knows Jest or Cypress or whatever it is, this is my first scenario. So if you look at test, it's an extension function on test. So Kalash, remember I said Kalash is plugins. So Kalash basically plugins means extension, because then you can write your plugin in another repo by extending things. So scenario, actually, if you look at the block, I'm not sure everybody can read it, but it's actually an extension function on user. Well, because here you're going to describe what a user does. So what's the user going to do? It's going to perform an action. Whatever. It's going to click a button. So action is actually just an expand function. So, of course, we want to do stuff asynchronously. Well, we are coroutine land. So it's not that we want to do stuff asynchronously or non-blocking. We want to never, ever do something blocking. If you start using REST template in here, the whole thing dies. Mostly also the tests that we run them with one core and 1 GB of memory. That's the workers that we utilize. So we have one thread. Like the whole thing runs in one thread. That's really easy because you have 0 concurrency overhead. And again, that makes it simple. And then we scale horizontally, which makes it also really simple because you have no controller. Whatever. Let's say default random. Does anybody know what the...
Probably want to get the Kotlin one rather than the Java one.
Yeah, that I'm completely right. Random.default I want to actually have. So Kalash is very, if you fail a scenario, the user dies. The system, of course, doesn't die because, well, stuff can go wrong. So it's just telling you that it went wrong. And if this action is executing, well, sometimes going to throw, sometimes not. So let's see. Yay. So there's nothing there yet. I'm not sure how it got that weird time frame. It must be in the code somewhere. I have no clue. So, well, the user's gonna ramp to that. So let's not do that. Let's just say go to 50. Otherwise, it will take ages. Yeah, and hold that for a while. So we have test. It has this one scenario. I'll go into how you can do different things. And that has this action. So again, I mean, Kalash is just measuring this thing. It's measuring the execution of this lambda. And in this case, it might throw, it might not. So let's run that. Oh, hey, that's odd. It's throwing every now and then. That was totally unexpected. So, I mean, of course, a user can do multiple actions, right? So, but this action is actually gonna, it's gonna delay for 100 milliseconds. Remember that I said you can just program in stuff. You don't need to like, you use this scenario and everything else, just do whatever you normally already do. So let's see if we got some stuff here. Yay! So, well, it seems that sometimes it's failing. Also, here's the ticker. So the ticker basically is, it ticks every second. So it has ticks and it has skips. If you start seeing skips, something there is probably not working out. So you see here we have virtual users. No ramp up, just started. We're going to the fifth scenario, so it's about halfway up, right? Random, like halfway is true, halfway is false. This is the throughput per second. It's kind of a lot. That's actually a click button is doing that. The latency is below a microsecond. Well, that's just execution time and the Kotlin coroutine runtime, because coroutines are definitely not for free. I'm almost at time. Anyway, so let's, that already do that, so I can do this. So let's it keeps on running. So we have a plugin called Web Client, and it gives you an actual web client. Thank you. So, and a bit of an extension method that we added. So, yeah, so actually, I mean, web client, just, okay, so remember that I said Kalash is only plugin based, so web client is actually an extension on user. And action is the thing that measures errors, right? So you can see that here we actually call action and forward the name that we've passed to it. So action is just, a web client is just a wrapper around an action that you perform with web client. So let's see what that does, because we saw that how this was working out. So I think, yeah, so this all of a sudden had latency. So the 99.5 latency was this. So let's see. Yeah. And this was the 50. Remember, because the half of the time we went actually 100, the other time is just plain old execution. So it gives you these percentiles, gives you the error margin. And of course, currently we are no longer given error. So this localhost 1990 is, by the way, where Prometheus lives. So I'll use this as an example because it's easy to. So you see that it starts, it actually does something. But you have JIT compilation, so it will get faster and faster. It usually ends up at like 3 to 4 milliseconds. Throughput is slowly going up. You have a bit more metrics here. You can actually see what the CPU does. Well, this is interesting if you're running it in the cloud. Then you probably want to know how much CPU you're using. So is the skipping that I observed due to my machine being throttled or being fully utilized? Or is it, so this is why you also need to take into account your actual resources yourself. So if it skips, check if you're the bottleneck by looking at the resources. If not, that's probably the other thing that you're testing. If you want to do something before your tests start, well, actually the scenario is the thing that is running, right? So what, yeah. So sometimes you want to do something with a user. Yeah. Stupid. So why do you want to have this on the scope? Well, let's say you're dynamically fetching data, right? So this scenario is running, being ran by 50 users. So you can't just say, I'm going to create a list here, and then I'm going to get a user from that list. So because it's running concurrently, your data structure needs to be concurrently. So, yay. Let's see. Oh my God. So I'm running out of time here. There's so much to tell. So if you do this, you get a received channel that gives you an int. So you could do now here. And this is how you would actually, so this could be just a file that you read, right? Well, not entirely. Let's imagine this. You have one file, you have 20 workers running, and that file contains user accounts. And then all of them 20 start at index 0. And all of them 20 start to log in as user A. Okay, that's completely messed up. So, but you don't have that in Kalash because it focuses on a single node. However, you need to solve this problem if you start running distributed. So we have a Kalash K8, which is basically a piece of Java code that you use to start Kalash in the cloud, and you tell it the number of workers. And it spins up your Kalash pods, it waits for them to all die, and then it goes down. So it's basically a controller, but it doesn't interact with any of these pods. These pods don't know, but it is the parent. So if you keep, why is that? Because I want to kill my 100 running workers at once by killing the parent. So Kubernetes has a concept of a parent job. So this is why we create one parent job that spins up all the workers, so we can kill all the workers. Plus, if I do another deployment of my test, I want that deployment to kill the old one and start a new one. So this is why you need that kind of a mechanism. So what does it do? Well, if it spins up, every worker, as you know, gets told by an environment variable how many workers there are and what its index is. So it can actually do a modulo operation on the index of the line in the file, and it can give every node its own user from that list of users. And to prevent any issues, so you don't need an eternally long list, it will automatically, well, in editors it's line wrapping, but it will just start at the beginning, and it will start. So basically what happens is one node reuses the same kind of workers, just like if you would locally, that single node would use all the workers and start from the going. I could talk a lot more, but I'm afraid I ran out of time, so yeah, I'm pretty happy with it. Thanks for taking the time to listen to it, and that's it.
Maybe some questions? Offer.
Yeah.
You're saying that you're using modulo to run over the sections of the different users that you can use. So does that mean that every worker uses like a subsection of?
Yeah. So user 1 takes index 0, user 2 takes index 1, and if you have 2 users, then user 1 takes index 2, and user 2 takes index 3. So they just jump over each other. Yeah. So all the users are in fact used in the list, but I just made sure that all these workers do not interact with each other.
Yeah. So I was just confused about the modulo operation because but this is a different mechanism. Okay.
Yeah, it's basically what Hadoop used to shard stuff, and what basically in the past was used to do some simple retarded sharding. Anybody else? Any questions? Oh my God, him again.
This use case, it just shouts Hazelcast, right? To make sure that my data is nicely distributed over all my Kalash things.
Okay, so I can tell you that nothing ever shouts Hazelcast. Like there's nothing in this world that shouts Hazelcast. Yeah, I mean, when you start doing clustering, you'll make things a lot more complex. You need to have leader election, and you pull in all these kind of things. While in fact, most performance tests that we run are that bit easy. So why would you introduce that kind of complexity in something that, in essence, could be that simple?
Because it's cool.
If you think Hazelcast is cool, we need to have a conversation, Leon. Okay. You have a lot to learn. Yo.
Where can we find this? Is it open source? Can we use it? Can we?
So I'm actually talking about this. So what the plan is that we're looking at the adoption. I mean, first litmus test, of course, is what do the people inside of the company think? So what we see is that every week there's another team starting to work with it. So it's growing, and we're not trying to make it grow. I think it's going by word now. So I think in a couple of months, we'll see what the adoption rate will keep on doing, what percentage of the actual applications, Spring Boot applications, are tested with this. And if we can warrant actual operational excellence over it, I mean, somebody needs to maintain this, right? Because people are using it, you need to take responsibility. This goes internally, but even more so if you have a public product. I mean, if Bull open source this, everybody thinks, yay, and we stop caring, then we look like idiots. So it's important for us to make sure that we commit to maintaining it. So I'm hoping we'll open source it, but it all depends on, well, it does not depend on me, basically. So I can't answer that. Sorry.
But it's 250 lines of code, so that's...
I think it's ridiculous to not do it, but yeah, I find a lot of things ridiculous, so I'm not sure that's... yeah.
I had the same question.
Oh.
Okay, sure. So,
maybe online there are some questions, Joachim? No?
a lot of...
Oh, one more question.
oh, Joost.
So you mentioned that the performance test should be isolated, it's run on isolated things.
Yeah.
But if I understand correctly, Kalash doesn't really help you to do that, right? Like I guess you could set up your wire mark and everything here to isolate. But
So we are actually... So it's a very good question. So this was something that didn't fit anymore, so I just left it out. But what we're doing is moving the test in the performance center to integrate it to the cloud integrated using Kalash. So the next step is, and teams are already doing that, is Kalash is just a part of your application, right? It's just yet another module where we bake another image that we deploy to run your tests in the cloud. So what you want to do is, if you want to have predictable tests, you want to know, like, if I do A, I get back B, right? That's what you can do to mocking. But it's super convenient for these two things to live in the same technology in the same project. Because then, so what we do is we've created an application around WireMock. Kalash, I can show there, but Kalash basically always sends these, well, oh man, that zooming in, zooming out. It always sends these headers. So we forward these headers, and WireMock is always running in the middle. It's a proxy by the, just we transparently proxy everything on the Akom environment. And as soon as Kalash starts running, these headers are being forwarded by Spring Sleuth to the WireMock, and then WireMock all of a sudden starts responding with mocks. So the idea is that you always have this running, this WireMock, you just go through it, so everybody who does normal integration testing actually hits the back-end systems. But as soon as we start running our test, it detects these headers, and then based on the scenario and the action name, it knows what response to return. So we're actually and this is how we want to do a couple of things. One, we want to optimize like what resources do we want to give that node for it to optimally function vertically. So after that, we can scale it horizontally because we know the optimal setting for this. And then the master plan is, of course, that if we have that, then we start automatically tuning the GC. So you run this application, have it integrated, start performance testing it, bring it down, set some new configuration for the GC or the memory or the whatever, spin it up, run the test. So you can start automating that. And that is so much more controllable and easier if you do it mocked than if you have that landscape to do all kinds of gnarly stuff. Yeah, very good question. Thanks for asking it. Yeah.
The follow-up question would be, do you see the database that service typically used as a thing that needs to be mocked?
No.
Or do you think that this
No.
needs to go to
So,
the service?
I tend to, in my product, Mitch and Boyd know this, but I tend to talk about systems. So you test a system. And a system is something that is a logical unit of functionality that has an API and it can have a database. So you test this, if you look at isolation of concerns, this is a logical unit, like whatever, some kind of an entity with a REST service or whatever and a database. But that is the system. You test a system. And some system with aggregation you can mock because they go to other services. Your database, you for sure need to use that database to configure your application. But you also need to test the database because eventually you want to also see how many read replicas or whatever you need to set up. So it's a bit different, but no, you don't mock your database.
And you want to probably test against the service so the autoscaler can kick in so that you actually know whether your fully scaled system is.
So step 1 is determine how a single node functions and how you want to scale that. Step 2 is, and this is where the periodical comes in, periodically you want to see that that whole system and the scaling, everything else, works as expected still. Just like with functional testing, because you want to test in isolation, but you also want to test that your network stuff is properly set up, right? And that the configuration makes sense. So it's never a goal to only do things in isolation, but as much as possible, just like with this test pyramid. Yeah? Can I get a Coke now? Thanks.